those fancy rigs I see people sometimes carrying around, and all I gotta do is carry this goofy microphone rig. All right, I think we're live. I don't know. Hey, morning, evening, afternoon. Hi, everybody. We are at Devox, Belgium. I'm joined by Thomas. I can't pronounce your last name. I can spell it. We saw that, right? I've learned how to spell it.
Yeah, that's right. It's Thomas Wuerthinger.
Multiple syllables, not good for me. My brain is very smooth.
That's right.
But Wuerthinger?
Wuerthinger.
Okay.
Perfect.
Sorry that I butchered that. You are. Well, we just got off stage.
Yeah, exactly. We're just at this talk about beautiful GraalVM.
Yeah, it was actually one of the best experiences I've had at the show was just getting to be there with you today. We did this talk at Spring I/O a few minutes ago or years ago.
Yeah, it was. We did our first talk together back then, but it's actually since then like we have added a lot of new things related to GraalVM and that we showcased today. Which
I don't think people knew what they were going to get into when they came to that talk.
That's true.
There's no way they could have, like that was.
Yeah, but I guess when you see the Spring shell in the browser, it's something you cannot unsee.
No, yeah. So we did a presentation. We looked at. Well, I mean, let's just talk about it. What is new? Because we did a recording here at the show last year, I think. Or was it 2 years ago?
Yeah, that's true. I mean, we started out with the basics, of course. We always with GraalVM, we improve startup, we improve memory footprint, improve our peak throughput. These are the performance metrics, right? These of course get better from version to version, and I'm very happy that we can now compile a Spring application in 30 seconds into a native image.
Yeah, and it was. We didn't even need the music.
No, we didn't even need the music. It wasn't even necessary.
You showed things that were unspeakable, and
yeah, we then got a little bit into the more crazy realm. Well, first we added then like some Python to the Spring application,
which is really cool, useful.
Yeah, it's useful when you have like some Python module that you really want to depend on, like Markdown, Dockling are very important Python libraries to extract things from documents, for example.
Yeah.
But we then even later showed a demo including Hugging Face transformers running in GraalPy on your Spring applications,
right?
And do LLM inference.
What broke my mind is because I'm all about integration. Java is the glue of the enterprise, right? And the JVM is the glue of the enterprise, right? And so to the extent that I can take advantage of other people's cool stuff and other ecosystems, I'm all about that. And
yeah, exactly. And you don't want to like when for some reason you have like a good Python library you want to use, you don't want to like stem up another process with Python and define a REST interface between your Java process and your Python process. It's all very complicated.
Yeah.
And for us, we can run Python and Java in the same process, and with the same VM, with the same configuration of the heap,
and the same threads,
and
right?
the same threads, the same cheat compiler. So this means that it's much more uniform kind of execution, and it's much faster to do.
And more secure.
Yeah, of
because you get the same static self-contained images.
Yeah,
and
it's all self-contained. You can create a native image out of it. You can either run it in JVM mode or native image mode.
Right.
And so that features something we have been building up a lot, and now it's at the point that's really usable without major development hurdles. Because there was a bunch of things we needed to fix in the development process where do you put your Python dependencies? You can put them into your Gradle and Maven files now. And so where is the directory created with those dependencies? Where does pip install those dependencies? Those were things we had to get right before it's really usable for a lot of people. But now we're at the point that we could show on stage that within like 5 minutes we added this to the Spring.
It's true. Really impressive. We showed, and then the other thing you showed that was like mind bending was we took a Spring app, a trivial one, not fully featured yet, not really. I won't say it's like 100% there, but we took a Spring Shell app.
Yes.
And got it running in WebAssembly, right?
Yes. Because one of the exit targets of native image is either the machine code or it's WebAssembly.
What?
And then you can take the WebAssembly and run wherever WebAssembly runs, which includes Node.js.
Right.
It also includes the browser, of course, and that's why we got Spring Shell running in the browser.
We're so back. It only took 30 years, but Java's back in the browser. We did it.
It's so back.
So back. What is the what like? Did you start the? Is this a thing you get from Clang, or how did you get to the WebAssembly output? Is that a
no? It's just a different backend from our end. We have a backend to our typical backend goes to binary. We have one backend that goes actually to LLVM bitcode.
Yeah.
This is for cases where you wanna like you want to use a target architecture that's very special that we don't support ourselves, then you can go to LLVM bitcode, and then you can use LLVM to compile to PowerPC or whatever.
And that includes the RISC-V support.
Yeah, RISC-V support, exactly. RISC-V, PowerPC, and others.
Yeah.
Because we only support ARM x86. So that's. But then, in addition to the LLVM bitcode, we have now another output format, which is WebAssembly. And
it's just so cool.
Yeah, it's really good things you can do with programs, transpiling them once you have like this view that native image has, because native image has this full program view, where it analyzes the program and knows all the dependencies and everything's included. So in this scenario, it's much easier to transform the program into something else and run it into some other context. And this is why now when you write a Spring application, you don't need to be worried that in the future you will be boxed into a certain piece of technology, because there will be multiple target architectures. There is Python support now if you want it, right? So these kind of technologies that connect your ecosystems can be quite powerful, and they make sure that whatever investment you make in, let's say, your Spring application is not lost in case there's some other technology that you need to connect to. Right. I think that's the key value add here. I think to the ecosystem, that you give people more choice.
Well, of course, I'm a big fan, but like you said, it's not just that you've made it so that you can take existing, I can take existing Spring code and make it more secure and reduce the footprint and improve the RAM and all that. But now you've opened up new opportunities that just didn't exist.
Yes.
Why did you? What are the use cases for WebAssembly? I know it's more secure. It's got its own little sandbox notion, and you can interoperate with other libraries.
Yeah, and there's maybe just some places where you can only run WebAssembly for certain reasons, because maybe a place would not allow you to run native code, right? Yeah, and that can be a browser environment, can be an edge computing environment. Very true. Where you are constrained to this format, and then this is one of the options. Yeah,
and it's very. So, is there support for one of the nice things about WebAssembly is I can link to other WebAssemblies written in other languages. In theory, they can be.
Yes, you can link them together. Yes.
How can I do that with this? That would be.
You can, when you create this WebAssembly, you can export symbols and then you link it together with others.
But can I in my Maven or whatever pull in other WebAssembly modules and link that to my code?
I think you would do it afterwards. I think you would create a WebAssembly and then link it together afterwards.
Okay, interesting.
In a post-processing step. And WebAssembly is a very interesting format, we are collaborating with different entities in the industry on WebAssembly, and we hope to do more of that in the future.
So you got WASI and all these.
Yes, we wanna. The main thing is currently missing for being practical is the WASI integration, the WebAssembly system interface integration.
Right, and that gives you the access to the external network services and file systems.
Yeah, it's network service access, file system access, and these things are defined in this WASI interface, and we now need to make
projects
sure,
for WebAssembly.
Yeah, exactly. We need to make sure that we support the translation into this format.
Yeah,
and we are hopeful that we will get there, and then once that is out, then it's available for the masses, because now it's more like a party trick, let's say, to run. It's a very cool party trick, but it's a party trick. It's still in the party trick phase, where you can run the Spring shell in the browser, but we are getting
nothing, by the way.
Yeah,
it wasn't. By the way,
no, it's not nothing. But we're getting now. Maybe 12 months from now, you can say we will be at a stage where it will be all of the rough edges are flashed out, and so it's currently, this is one of our preview things where we are we get something running, but you want to make sure that the developer experience and the integration experience, is just much better. With Python, we were there 1 year ago. Yeah. But this year, I think at this stage, it's mature. Yeah. It's it just works.
Let's talk about that. So you got I remember a couple years ago, WebAssembly there's garbage collection finally. There wasn't originally.
Yes,
and they had
that was a big
game
add,
changer.
big change. Yeah, exactly, for us, because when we compile and manage garbage collected language, cross-compile it to WebAssembly, otherwise we would have to ship our own GC there, which is very awkward. They also didn't have certain facilities to even allow a GC to be built there, or stack walking wasn't really there. So it was very, very awkward to target it as a platform. But now with WebAssembly garbage collection available, now it becomes much more feasible, and our web assemblies have gotten a lot smaller.
Yeah.
And so now it's actually a viable system to target.
It's amazing. Okay, so this WebAssembly. Well, I'm going to ask you about this again in a year.
Right.
Or whenever you come back on the show, if you deign to come back on the show. Last year, I think it was, we talked about. Is that Crema? Last year you talked about layers.
Yes, we had native image layers. They are currently available in experimental form, where you can build a base layer. It's a base shed library.
Yeah.
And then you build an extension layer on top. And one of the things we are focusing now a lot on is what you call Project Crema, where the extension layer is going to be an interpreter of GRAM bytecodes.
Okay.
And this interpreter of GRAM bytecodes can then run and dynamically load arbitrary classes. So this is so now you're no longer restricted to everything that's put in the image, but you can actually extend the application by dynamically loading code and executing.
Wow. Wow.
And it kind of gives you control in terms of like, well, what do you want to ahead of time compile? This will be in your native image layer. But then you can, for example, open certain parts for plugin systems, for example, where you say, okay, this class should be extensible. I mean, a very prominent example that we want to support in this way is Java-C with annotation processing.
Oh, right.
Like when you pre-compile Java-C, you get a native image, and it's actually a very fast Java-C because it starts so compile. But currently, we cannot support annotation processes in Java-C,
which is
important.
Lombok is crying.
Yeah, it's kind of but I mean, many are using annotation processing, including all of the frameworks.
Right.
And so in that case, now we can with Screamer we can create a base image of Java-C, but the annotation processor runs then in this dynamically loading code.
To fill in the last bit that can't be pre-compiled like that. Okay.
Yes, correct.
That is so cool. And Crema, Java, coffee, cream.
Yes.
You are good with names, that's for sure.
Oh yeah. Like hopefully it will stick the name. Yeah.
So that is a thing you can already get access to. Is the idea that you can?
Yes, I mean there is an early access build where you can have a flag that is called plus runtime class loading.
Okay.
So runtime class loading is the flag, and if you add it to a native image, you get Crema included. In the latest early access build, it's available.
So is that for GraalVM early access? I just look for that.
Yeah.
Okay.
Yeah. Just on our GitHub releases, the latest early access on our GitHub.
Amazing.
Open source community releases.
Amazing.
So you can download it, and you can do plus runtime class loading. And it's also for use cases where you want to use a native image with, let's say, ByteBuddy,
right?
Or one of these, bytecode generation frameworks. And but it's experimental status at the moment. But if you are like, for example, a framework author or like a library author, want to play with it and want to give us feedback, I think it's currently in this stage of development. It still has a couple rough edges. The demo today was crashing on me, unfortunately.
That was just the misplaced file. That's all.
Yeah. But you can see the usability and is not yet in the same level as with our more mature features.
Well, this is why we have these podcasts, so we can do interval checks. That's all.
Yeah, and that's why we, and as a GraalVM project, we have a little bit more risky, like very few experimental features,
right?
Because we have these collaborators in the industry, like the Spring team, that want access to those before they get fully released, because they can give us valuable feedback, testing. And so once we're in the full release mode, then it's fleshed out.
One of the things I don't think people appreciate is because you just mentioned the collaborators like the Spring team. We were big fans, obviously, and we have a whole new component model since 2022 or 23. When did we release 6.0? We have a whole component model that exists at compile time. Largely at the time that the impetus there was to make it so that we could target a GraalVM. And so one of the things that's always made me really happy is just we are starting to ship things that we can either create a thing that starts at runtime and does dynamic things at runtime by doing cglib proxies or whatever, or different pathway, we can do code generation. So we can reify what would have been done as code generation. We can turn that into actual source code that gets generated during compilation. And like Spring Data now, the new Spring Data coming out next month has AOT repositories. So you create these interfaces that have a dynamic finder for data in a database or whatever, and we can actually code generate that repository for you now at compile time with that same component model.
Yeah, and this kind of compile time, doing work at compile time, that fits very well with native image.
Yeah,
because
good.
it reduces the dynamism. And in many scenarios, when you create such a server-side application, this is what you want.
Yep, and you are, I'm sure, too busy, but I do a lot of talks these days on AI, just so you know, right? And so I'm a big believer that for 90% of people's use cases, it's just talking to a REST API, right? Most people aren't gonna train models.
That's right.
But big but, there's some people that will, and at the moment, I can wait for Valhalla and all this other, and the vector API, all that stuff will arrive eventually, and I'm sure Java will take over in 10 years or whatever. But in the meantime, it's a Python person's game, isn't it?
Yes.
And I think having the ability to securely and scalably do that.
Yeah, but it's not only from Python. It's not only training models, let's say, or anything like that. It's like there's many interesting Python libraries that either pre or post process what comes out of a model.
Yeah.
And the code of those is typically running on the CPU.
Mm-hmm.
When we showcased today in the talk this Python library to extract things from documents.
Right.
It's a pure CPU-based task.
Yeah.
And you don't want to for this case go out of your Java environment and stem up another Python service just because you have to, right? Now in the GPU space, there is, by the way, another very interesting project that's based on GraalVM that is the Tornado VM. And this is the currently best available way to offload Java code to the GPU. So if you really go into the weeds of let's say I need to write some code that has to run on a GPU,
right?
And I want to connect it with Java, then also Tornado VM based on GraalVM is
already here today.
Yes.
There's no reason not to be on the JVM these days.
Yes.
There's just that ecosystem.
Yes, absolutely.
Oh man, that is so cool. I don't know. It sounds like you've already solved many of the problems of tomorrow yesterday. So, what are you working on? What's the forward-looking thing that we don't know about yet?
We wanna So we mentioned Kramer here, right? So Kramer is currently experimental. We wanna make it fully featured, fully stable,
right?
To make sure that the Kramer use case is 100% covered, right? And the other area that we are investing quite a bit is indeed Python, because our Python implementation is pretty good, but
it's the most popular language in the world right now.
Yeah, it's the most popular language in the world right now, and we want to have an even faster and leaner Python execution, which will benefit the Python integration with Java. But eventually, we also think that we can be attractive even for people who are doing pure Java or who want to primarily program in Java and then maybe use primarily program in Python, but then use a Java library.
That's so cool.
So this is an area that we kind of invest quite a bit. Yeah, the inverse, exactly. And we, the GraalVM team, from the beginning, our project was always multilingual.
Yeah.
We are not we like programming languages in general. And so for us, the three major pillars is now Python, JavaScript, and the JVM ecosystem.
Right. And the JVM, of course, buys you a lot of languages as well.
Kotlin. Yeah, like Kotlin, for example, or other languages, Scala. We were always very good in executing Scala and still are.
Right.
So if you have a Scala program, it definitely will run, almost certainly run faster on GraalVM.
Isn't that the original? I remember our friend Chris Tallinger over at Twitter years ago.
Yeah, Twitter was using Scala and GraalVM quite a lot, probably still
as a JIT, right? Only
as a JIT, because the GraalJIT compiler is
phenomenal.
Doing good escape analysis, and that's good for languages like Scala or Kotlin.
Hey, I could be speaking out of turn here. Forgive me. It's been many years. I haven't seen Chris in a long time. I'm sure he's okay, right? But
Chris is fine, but he is currently in Hawaii and I think surfing on a beach, and so
great guy.
Yeah, great guy.
Anyway, he was, I think, and again, my memory's, he was talking about 10% reduction in memory or something like that with the JIT.
I think it was a little bit above 10% in reduction in CPU, better throughput. That's
just stock standard Java too.
Yeah.
It was just that much
that's
better.
In general. If you have a Spring application in general, and you don't want to talk, there is no need for native image. You can just use the standard Graal distribution without native image.
Yeah.
And it's very likely going to run faster.
So you guys come out of your sessions.
We're on a podcast. Yeah, hi. No problem. We'll be done in a minute. Sorry, friend. Thank you. So anyway, We are live. We're actually at a conference here. We got a background here, but there's
That's
people.
right.
So yeah, just 1 out of 10. You got a Spring application, 10%. You can run cheaper. Like if you have an instance that has 5 instances, whatever, or 10
it has
instances.
a better script. And you can just try it. It's like just setting a different Java home directory.
Right. That's free scale. How do I get access to the JIT these days, by the way?
To the JIT, our last release still includes the JIT, the 25 release.
That's so good.
You just download it. You use SDKman to install it, and you're done.
Okay. And there's there's a open source GraalVM community, and then there's a few features that are like
that are in the
commercial.
Oracle GraalVM edition, but it's a Oracle GraalVM edition with the free Graal license, which is free for production use.
Okay, and so that means I can take a binary that's compiled as a native image and run it in my server.
Yes.
No problems, no constraints.
Yes. The only constraint is that if you create a binary and you sell that binary to somebody else, then you would need a commercial license.
Yeah.
But if you build it for yourself or for your company, and your company wants to use it in production for any of the production services, not a problem.
So if I serve a website or whatever,
it's not a problem.
It doesn't matter if I'm charging for that website?
No,
okay.
That doesn't.
It's literally the distribution of the binary.
Yeah, exactly.
Okay.
It's the distribution of the binaries.
I see. Okay, that's amazing. I mean, that is like, and that gives you, that PGO is really, that's rocket fuel right there.
Yeah, the PGO is a nice feature of native image because it allows you to train the application on the kind of workload that you want it to be fast.
Yeah.
Because typically when you run it in JIT mode, it tries to optimize the application based on its startup behavior.
Yeah.
But this is not always optimal.
Yeah.
Because the application startup does maybe something else and you want it to be faster. And so with GraalVM native image and PGO now, you can train the application and the kind of workload that you think is most important to you.
Wait, can I put you in a counter posture here? You just showed actually how freaking amazing GraalVM is. You started a program and then barraged it with you had to go to 1 million to get
1 million requests and it was still the same throughput.
Yeah, so like even though the JVM JIT kicked in after 100,000 or something like that.
It's not fast.
And it was not faster.
No.
So the GraalVM image there was already even after the JIT kicked in, it was basically the same. Yes. And then for the first 100,000, it was a lot faster.
Yes, correct.
Right.
Because your speed is instant. You don't have like a warm-up curve.
Right.
And the warm-up curve for some applications in JIT mode can be huge. It can be like, I've heard of applications that take like an hour to warm up. Because if you have a ton of Java code, then it really takes.
Well, I remember large organizations like Google and Amazon, whatever. Used to warm them up.
And with native image here, like your peak performance is practically instant.
That's amazing.
So it's and it's specifically for applications that have a lot of code that is hot at the same time.
Right.
Like if you have an application that has just one small loop that is dominating everything, then the JIT compiler can compile it and it's fast, right? But if in an application where a lot of parts are hot because it's a complex piece of code and there's no loop that is dominating everything, it's actually very hard for the JIT to get to the right performance because
it doesn't know where to start.
Yeah, and also like the interpret is 50 times slower. So now you need, if I compiled 99% of the code, but I'm running only 1% of my code still in the interpreter, I'll be still 50% slower.
Right.
Because it's 50x.
Right.
So I need to JIT compile more than 99% of the code that is running. Right? Now, that is possible quite easily if you have one loop that's so hot that it's like 99.9% of the app.
Yeah.
But if you don't have that hot loop, it's actually pretty hard to get there. To this like full coverage of everything JIT compiled, right? And then the other thing there, of course, is you need to have like the code cache configured.
Yep.
You might run out of code cache. You need to remove then things you JITted before and so on. It's all a very, very complex and tedious task to tune the app.
Yep.
And it's
non-deterministic for most people.
Yeah, it's non-deterministic and it has performance pitfalls. But maybe if your code cache is too small, performance of your application might drop like power. And what we get here with the set-of-time compilations, like a predictable performance, use it what should be fast with PGO if you want it, right? And there's just no disadvantage.
Amazing.
The only disadvantage is, yes, you need to, in your build pipeline, where you typically run anyway, like your tests and everything, you need to add like, half a minute, maybe maximum for building the binary.
And that's without PGO. It gets even better with PGO.
Yeah,
right?
of course. course. And the binary that you built here is easier to distribute, and so that's why we think essentially for server-side applications that ahead of time compilation, full ahead of time compilation, like native image does it, is a no-brainer. Because also like you otherwise you pay for compiling your application in production.
Which is, but you're shipping a compiler too. That's what.
Yeah, you ship a compiler.
You've got a compiler,
and then you pay for like in production, like your high availability server.
Yeah.
That is supposed to serve your web requests, and it's quite costly compared to your development machine, in terms of cost per CPU cycle.
Sure.
That one is then compiling your app, so it's much better to compile your app on your CI/CD infrastructure, which is much cheaper to run.
And just once, by the way, if you have 10
just
instances
once,
of the service, you have to do the same compilation 10 times.
Of course, just
on
once,
the JVM.
and you can start it multiple times. But it's just a cheaper setup because your CI/CD server has a much lower requirement for availability and so on, and therefore it's cheaper to run stuff there.
Right, that's amazing. So you said no-brainer. I agree, it's a no-brainer. But let's talk about you for a second here, right? What's the path? How does somebody like you get into this? You're doing the stuff that makes the Java community amazing. This kind of stuff is how people, we need really smart people leading the way for the community, for all of us to get that lift, And so I'm grateful for people like you, obviously, because this is not just like keeping up with the other ecosystems. This is in so many ways ahead of so many other ecosystems. What was your path? Did you wake up one day and say I wanted to build this?
But yeah, I mean, in general, just before, I mean, there's a large team here in GraalVM. I want to emphasize on that.
What is it now? A couple hundred, 5,000, 2?
It's a lot of people.
Yeah,
a lot of people.
Yeah.
But so and there's many of them very smart, very passionate. And
really?
while some people might be more the face of it publicly, right? There's really a huge amount of people behind it. And our aim is indeed, our aim is to kind of improve the ecosystem, give people choice, and so on, right? Not a parse. How I got there was that I always loved compilers and interpreters.
Yeah.
This was my first. When I started programming, was 14, 15.
The Dragon book at 14, huh?
No, the Dragon book. I was just doing that. Actually, I didn't have the Dragon book, unfortunately.
Okay.
So I was just hand coding some interpreter with template interpreter with C++. But I was fascinated from this meta-circularity of I write a program that runs my program.
Right.
So this was always really cool for me. And that's why later when I started university, I did mostly compiler construction courses and bachelor thesis and master thesis all on compilers. I did everything on Hotspot back then. So my bachelor thesis is the array bounds check elimination in the Hotspot client compiler.
The bounds check what?
Array bounds check elimination. So it's something that tries to remove array bounds checks based on conditions. This was my bachelor thesis. Doing my bachelor work, I was.
Is that inefficient? If does the JVM have to constantly check that you haven't exceeded the amount of memory allocated in an array?
Correct. Yes.
And
but then what it does is it tries to find boundaries of loop variables, and if you say, I don't know, if you make a for loop and you see I smaller array lengths,
right?
Then you array at I, then you see that I is smaller than array length, right? So you kind of try to prove conditions. Maybe it's a constant, but in this case you just prove the condition that it's smaller than the array length.
Okay.
And this then makes the code go faster. Yeah. So that was the part, and then later I went to Maxine VM, right, which is a research VM.
Yeah.
Then I went to Google V8.
At Google, the thing that launched Node, and
yes,
it wouldn't have been possible without that.
I was developing specifically for them the V8 crankshaft compiler.
What is that?
This is one of their cheap compilers they have in V8.
Yeah.
And they were shipping in Chrome 10.
Which is
and later I
ago.
came back to later I came back to Oracle because of Maxine and then because of the GraalVM project.
So the pipeline must be very small for the people that can do this kind of work in universities and all that.
That is true, and the specifically nowadays, because universities are also now very AI hype driven.
Sure.
So it's actually getting much harder for us to fill a good pipeline of students with more traditional compiler construction.
Right.
Also, we of course believe that long term there will be a need for also traditional compiler construction like we have been doing it.
Yeah, of course.
But the trends in academia have actually shifted to the extent that it's
even harder.
It's harder. Yeah.
That's really unfortunate. No, that's really wow. What a weird. I mean, you're like Java's Willy Wonka. You know what I'm saying? Like there's just a lot of really cool stuff happening under your team.
Absolutely.
Sir, as usual, a pleasure.
Excellent.
Everything you're doing is great. I'm just a big fan. Hope we get to do this again.
Thank you, Josh. I'm a big fan of yours.
Cheers, buddy. Thanks for hanging out, everybody.
Thank you.
Bye-bye.